Hi, this is Brandon Baines in the Math Department at Lipscomb University. Here to talk with you today about applications of quadratic functions. In this presentation, you'll learn how to model real-world scenarios using quadratic functions. In App 3, we learned how to calculate a quadratic function's x-intercept, y-intercept, and their vertex. We also noted that the y value of the vertex represents a quadratic function's minimum or maximum value depending on the orientation of the graph. In this section, we'll calculate these values with quadratic functions in applied settings, and then we'll interpret those results within this settings. Consider the example of a pool diver that jumps from a diving board 60 feet above the surface of the pool. Her height above the surface of the pool, x seconds after jumping from the board, is modeled by the quadratic function h of x equals negative 16x squared plus 49x plus 60. Let's find the x-intercept, or septs, as there could be more than one, y-intercept, vertex, and the function value h of 1. After we find those values, let's interpret the results. The x-intercept is found by solving the equation 0 equals negative 16x squared plus 49x plus 60. That is, we're going to let the y value be 0 and find x. We can solve this equation using a variety of methods. One method would be the quadratic formula. Another method is to factor. An additional method would be to use some calculating device like a TI-8384 calculator or Wolfram Alpha. However we choose to solve this equation, we should end up with the solutions x equals negative 15/16 of a second and x equals 4 seconds. But negative 15/16 seconds doesn't make sense in this scenario. Since we're talking about a time, negative time doesn't make sense. So we'll choose to remove that solution or to not consider it in this scenario. So the only x-intercept is the x-intercept with an x value of 4 seconds. We'll note that I'm using the shorthand for stating the x-intercept by only stating the x value. Keep in mind that the x-intercept is an ordered pair, represented by the ordered pair, in this case, 4, 0. The interpretation of our x-intercept is that 4 seconds after the diver jumps, the diver will be 0 feet above the surface of the pool. That is to say, the diver lands in the water after 4 seconds. The y-intercept is found by letting the x value equal 0. So we'll find h of 0, which is 60 feet. So the x-intercept is 60 feet. Again, I'm using the shorthand for stating the y-intercept of just stating the y value. Keep in mind that it is an ordered pair, given by the ordered pair, in this case, 0, 60 feet. Since the x value represents time, and we've let x equal 0, and found that the y value is 60, this indicates that in the beginning, or after no seconds, 0 seconds, the diver is 60 feet above the pool. That would indicate that she's 60 feet, her board is 60 feet above the surface of the pool. The vertex is found by first finding the x-coordinate of the vertex using the formula negative b over 2a. Using that formula, we find that x equals negative 49 over 2 times negative 16, which is negative 49 over negative 32, which is 49 32nd seconds. That's a tongue twister. If we round this is approximately 1.5 seconds. The y value of the vertex is found by evaluating h of 49/32. Plugging in and computing this value, we find that this is 6,241 divided by 64 feet. This is approximately 97.5 feet. If we think about this setting, we find that this result is shocking. A diver is 60 feet high. Her board is 60 feet high. And we have just found that she reaches a height of 97.5 feet. When I first came up with this example, I realized that this maximum height was going to be too high. That is, the diver probably is not jumping 37.5 feet. I decided to leave it in this presentation because I want to remind us that we need to always stay plugged into our scenario. We go through sometimes in a math class and just calculate without thinking about the calculations we get. So I wanted us to have something shocking just to remind us to always think. So this probably is a non-realistic scenario unless the board is really bouncy. The interpretation then is that the diver reaches a maximum height of approximately 97.5 feet after about a second and a half after jumping off the board. The function value h of 1 will be found as we've been working with functions by plugging in a 1 for x in computing. And so we see here that we get 93 feet when x is 1. Since x is representing time, that would mean after 1 second, the diver has reached a height of 93 feet. And again, that must be a very springy board.